All right, you guys. So we're just going to talk about circles and not tangent lines here. We're going to talk about circles and just some circumference. So just where does it come from and how do we use that, okay? So I'm going to define some vocab we're going to use. So a chord is just a line segment whose endpoints are both on the same circle. So if I connect any dot on a circle with any dot, that's a chord, okay? A special chord is a chord that goes through the middle, and that chord is called a diameter. That's the longest chord in a circle. And then half of that diameter, or in other words, any point on the circle connected to the center is called a radius. So those are the three most common segments we use inside of a circle. Remember, if I connect center to side, I get radius. If I connect dot to any dot, I get chord. Whoa, I didn't connect those dots. And if I connect dot to dot and I happen to pass through the center, that's a diameter. Okay. All right, so then we also have two other lines. So what if instead of a line segment between any 2 points on a circle, it was a full line? We call it a secant. And then what if instead of hitting the circle in 2 points, what if it just skims? It's like laying a board on top of a wheel. Like, right, you have some wheel or circular thing and you set a board on top and it only touches at 1 point. That's called a tangent line. All right. Sorry. All right, so let's get going. So two new assumptions you can make this whole semester is if a line looks like it's tangent in this picture, you can go, yep, I assume that's tangent. And if a point looks like it's near the center, so if we put a dot like this, go, yep, that's the center. Okay, so if I put lines like this and a dot here, you go, those are two chords that do not go through the center because I see a big juicy dot near the center. So that big juicy dot is the center. So those are your only two assumptions you can make new. The other one is if a line looks straight, it is a straight line. We're not tricking you with like 178 degrees. All right. So another thing too is if you're naming a circle, you do it with this symbol. So circle W means you have a circle where the center is point W. Okay? Or in this one, circle R, that was a circle where the center is at point R. That's what that symbol means. Okay? So, first of all, what's this pi thing? You've heard about it, you've used it. So this pi, this never-ending decimal, right? So an irrational number means it's some decimal that never ends and has no pattern. So it keeps going forever, just random garbage coming out. But it has this exact value out to billions of decimal places. And we could use supercomputers to calculate out as many decimal places as we want, right? But here's the beauty of it. What pi actually represents is the exact ratio of the distance around a circle to its diameter. So if you literally took anything circular and just held a string all the way around it, right up to the edge, and said, okay, so here's the circumference, right? That's the distance around a circle, the perimeter of a circle. And then you went right through the center and said, here's the diameter. The circumference is exactly pi of the diameters. So in other words, if I laid a string out that was diameter long, it would go about a third of the way. Then I'd lay that diameter out again, and I get about a third of the way. I'd lay the diameter out again, and I get almost the whole way. So 3 of those diameters plus a little more. So 3.14159 of those diameters is how far around it is a circle. Or in other words, the ratio of circumference to diameter is pi to 1, or pi. That's really what pi is. Just throughout history, people played with circles and said, there's this about 3 to 1 thing here. About 3 of these diameters go around the circle. Like if you roll a wheel and you're counting distance, just something to play with for thousands of years. Okay? So here's another way of writing it. Pi equals circumference divided by diameter. Or another way you might know it is if we just multiply by diameter on both sides, we get that the circumference is equal to pi times diameter, or 2 pi r. That's really just the definition of pi, but rewritten instead of as a fraction to be no denominators on bottom. That's it, okay? Now, here's a brief history of pi, okay? 2000 BC, so this is like 4,000 years ago, people were already playing around with pi. And we have different things written on different tablets. So, I mean, etched onto cement tablets from 4,000 years ago, they already knew pi was around 3 or 3.125. Those were the estimations they had back then. And then the Egyptians went ahead and said, actually, and they played around with math. I mean, the great libraries at Alexandria. So we already had pi down to 3.1605. Now notice, pi is just 3.14, so they're already within like 200ths, right? To 2 decimal places already in Egyptian times. And then Archimedes, right? Like Eureka, running around naked, floating in a bath with the water level rising and sinking and displacement. Watch, so many things he's famous for, right? But he narrowed it down by saying, well, I know a circle could have a regular polygon inside it, and I could find the area of that. Then I could find the area of a regular polygon outside, and using that, I could calculate the circumference. Oh, no, sorry, not area. The perimeter here and the perimeter here. And then he could say, well, because of that, I know the distance around this circle must be about, and he did this all using Pythagorean theorem on these regular polygons. And so he was able to say, well, the circumscribed regular polygon and the inscribed regular polygon put an upper and lower limit on pi. So he knew it was somewhere in this range. But then this guy from China, like 700 something years later, does the exact same thing and ends up getting pi to 5 decimal places. He had to have used, we've lost his books to the ages. His books just have disappeared to time. But he would have had to use a 24,000 gon, regular 24,000 gons to get that precise. Oh my gosh. And this is on pencil and paper with adding up hundreds of square roots calculated by hand. Woo! Crazy. And so then, since then, we've just used computers and calculus and more modern methods to calculate as to however many decimal places we want. But isn't that cool? Okay, one more note. Exact versus approximate. In this chapter, often we'll say, leave the answer in exact form or an approximate. So you did this a little in trig too, so especially 30, 60, 90 triangles. Remember, a square root is an exact value. It's got infinitely many decimal places. It goes on and on and on and on and on forever and ever and ever. If you punch it into a calculator, your calculator only shows you the first 6, 8, 9 digits. Depends on the calculator, depends on how many numbers are before the decimal, but it only shows you so many of the decimal places. There are infinitely many more. That's like me saying, tell me all of the creatures on Earth, and all of a sudden you just list my friend Joe and my pet cat, and it's you list the 8 most important creatures on Earth to you, but there's billions, trillions of others, like ants. I mean, there's more ant weight on Earth than there is human weight, right? So how many creatures are you leaving out there? So it's the same thing here. This approximation is just giving you the few most important, the biggest digits, but it's leaving out infinitely many more. So here's the exact value with the square root, or with a pi, for example, 12 pi, and then the approximate value, you plug that in the calculator and you get it's around 37 point blah. Okay, so here's an example. Find the circumference. If I go circumference equals 2 pi r, the radius in the picture is 5, because there was a big juicy dot there, so I know it was the center. So I go 2 pi 5, that's 10 pi. So the exact circumference is 10 pi. The approximate circumference is plugging that in. I get 31.4159 ... Okay, I like it this way. Book answers are often this way. It's okay either way. Just be clear that your teacher is not saying, give the exact answer on this question. All right, so let's do some problems. How the value of pi can be calculated. Well, circumference equals pi times diameter. So you can just divide by diameter on both sides, and you get pi equals the circumference divided by the diameter. That's how. What the heck? You could put a string around something and measure that. Then you could put a string across the middle and measure that, and then just go, okay, what was the big circumference length that I got with my string divided by my diameter length that I got with my string? Okay, let's do this. Name these. Okay, name the circle. It is circle shape E. And that's because we know a dot near the center, we can assume that is the center. Name a radius. Okay, so segment AE. So really any of the segments with E. So EB, EC, ED, those are all valid radiuses too. Okay, name a chord. So there's actually a couple chords here. We could say chord DB. We could say chord AC. We could say, I'm going to say the most obvious, I think, which is chord AB. Now, other chords exist. You could draw BC. It's just not drawn, but any 2 points on a circle you could connect, right? Between 2 points there is a line. Name a diameter. So there's only 2 shown. They pass through the center and are on the circle. So it's either AC or BD. And then suppose BD is 12 millimeters. Find the radius. Well, BD is a diameter, so the radius would be half of that, so it would be 6 and 6. Okay, so radius would be 6. Suppose CE is 5.2, so there's a totally separate problem. This is impossible because all radiuses are the same. So we throw that last problem away and we go, oh, radius is 5.2. Find the diameter. Oh, well, there's just 2 radiuses in a diameter, so you just add those together times by 2, and the diameter is 10.4. Okay, now we have a radius of 4 on circle W, so this is 4, and we have a radius of 7 over here, and we know that XY is 2, so XY is 2. Okay, find YZ. Well, if this is 2, and we know the whole radius is 7, we just subtract, and we get that that difference between them is 5. And then same thing over here. If we know the whole radius is 4, and this piece is 2, well, then that means this is also 2, because the radius has to be a total of 4. All right, so YZ was 5. IX is, oh, that's just the radius. That's silly. And then I to C, whoa, is the total. So that's 4 plus 4 plus 5 plus 7. So that's a total of 8 plus 12. Oh, 20. That was nice. Okay. Whoa, big circle, okay. Refer to the model of a Conestoga wheel, wagon wheel, okay. Let's do it. Name the circle. Well, that's circle R. Name a radius, so R to any of the points on the circle. I'll say RZ. And then name a chord. So I'm going to name the one drawn right there, so ZV, but there's other ones shown. For example, TX is a chord. So I'll do ZV. And name a diameter. Oh, I'll just do the one I just circled, so TX. Name a radius not contained in a diameter. So here's one that stops and doesn't keep going, or at least shown in the picture, but obviously we could extend it. So it's kind of a silly way to word a question. Okay, suppose the radius of the circle is 2. Find the diameter. Oh, well, if the radius is 2, there's just 2 radiuses, so you double it and you get 4. The larger, and I'm going to erase that, now we're back to square one. The larger wheel of the wagon was often 5 or more feet tall. Whoa. What is the radius of a 5-foot wheel? Well, if it was that feet tall, that's talking about the diameter here. So if that's a total of 5 diameter, then we just divide it by 2 and we get a 2.5 foot. Okay. If TX is 120, find TR. So TX is a diameter. So if the diameter is 120 centimeters, find TR, which is just half of it. So that would be 60. Because again, the diameter equals 2 times the radius. And so we just keep using that forwards and backwards. If RZ, so that's a radius, is 32, find ZW, the diameter. So we double it, 64 inches. If UR is 18, that's a radius. Find RV, another radius, so it's the same 18 inches because all the radiuses are congruent. It's the whole definition of a circle, right? It's just the same distance in every direction, and the collection of all those points equally distant from the center is the very definition of a circle. So XT is 1, so XT, that's the diameter. Find UR, let's find the radius, we just divide it by 2, 0.6 meters. Which is the same as 60 centimeters. Okay, notice these are actually the exact same question. Interesting. All right. Whoa, I like it. So the diameters of these are 10, 30, and 10 respectively, meaning in order. So 10, and then B has a total radius, so I'm going to draw it like that, of 30, and then this has a radius of 10. Find each measure if AZ, oh, Z is pointing right there. So if this teeny segment there is congruent to this teeny segment there, so just zooming in, I marked this segment right there. So that's congruent to the mirror image on the right. All right, and CW is 2. Oh, so that means this is 2, and this is 2. So the remaining portion of that radius must add up to 10, so this must be 8. And then the remaining portion of this must add up, no, not that. The remaining portion of this radius must also be 10, so again, that's 8. Okay, and we know this whole radius is 30, so that means the remainder is 22. And same thing on the other side, 22. And then it just says find all these things. So AZ was 2 because it was the same as this. BX would be 22. YW would be, whoa, we have to find what Y is. So YW is 8. Z to X is 8. B to Y is 22. And A to C. Oh, look at that. I'm getting silly little things. Okay. And then, AC is, whoa, we have to add this. So we have to go 2 plus 8 plus 22 plus 22 plus 8 plus 2. So we get 64, I think. Perfect. All right, let's do one more. Whoa, look at all those crazy circles. So they all intersected. Oh, that's good. And then it says GH is 10. So if this is 10, that means this is 10. That means this is 10. And this is a circle with center here. So that means we have a radius in both directions. Now, if the diameter here is 10, that means that we have a 5 and then a 5 over here. But look at that. We have another circle whose diameter is 5. So what that means is we have little tiny radiuses of 2.5, 2.5, right? Oh, what a cool problem. And it just asks us to fill it all in. So F to G is a radius of the big circle. F to H is a diameter of the big circle. That's 20. G to L is the diameter of that medium-sized circle or radius of the big circle. And then G to J is half of that, so that's 5. J to L is also 5, and then half of that is JK, or 2.5. Very cool. Oh, and that was it. What a cool little intro, you guys. Enjoy.